This is Euclid Book 10, proposition number 43. A first bimedial straight line is divided at one point only. Let AB be a first bimedial straight line divided at C. Okay, so we have line AB here. It's going to be divided at C. So that AC and CB are medial straight lines. Okay, so AC is a medial straight line, and CB is also a medial straight line. And they are commensurable in square only and containing a rational rectangle. This is by Euclid Book 10, proposition number 37. I say that AB is not so divided at another point. For if that were possible, let it be divided at D. So, if it was possible to divide this line like they're saying it's supposed to be, it would be divided at D. Also, so that AD, DB are medial straight lines commensurable in square only and containing a rational rectangle. Okay, so now we have AD and DB, and these lines are now going to be medial straight lines. They're going to be commensurable in square only, and they're going to contain a rational rectangle, which of course we're going to find is absurd, but okay. Alright, since then, that by which twice the rectangle ADDB differs from twice the rectangle ACCB. So here we go again, we're going to be drawing rectangles. The first rectangle, ADDB. Two sides AD, two sides DB. Okay, now we got another rectangle, ACCB. Two sides AC, two sides CB. Okay. So, as twice the one rectangle area is to the other, okay, let me say this again. Twice the area of what, well, I'm having a hard time saying this. Twice the area of one rectangle as it is to twice the area of the other rectangle is the same amount of difference as the squares on ACCB. Well, we're going to make 4 squares. First one's going to have all 4 sides AC in length. The second square is going to be CB. So CB is right here. We're going to make a square, and it's going to have all 4 sides CB. The next square we're going to make is AD. All 4 sides are going to be the length of AB. And the fourth square is going to be DB. So all 4 sides of that square are going to be the length of DB. So as twice the rectangle of ADDB differs from twice the rectangle ACCB, that amount is the same amount that the squares on ACCB, if you add their areas together, is different from the squares on ADDB. Okay. While twice the rectangle ADDB differs from twice the rectangle ACCB by a rational area for both are rational, therefore the squares on ACCB also differ from the squares on ADDB by a rational area, though they are medial, which is absurd. This is by Euclid Book 10, proposition number 26. Therefore, a first bimedial straight line is not divided into its terms at different points, therefore it is so divided at one point only. And that's the proof. Alright, if you drew all the squares out, you can see this all for yourself. I will tell you more in a future video. Stay tuned.